Hey everyone, welcome back to the channel. Today we'll explore two key concepts in reinforcement learning, Q-Learning and Markov Decision Processes, or MDPs. Let's start with Markov Decision Processes, or MDPs. MDPs provide a mathematical framework to describe decision-making in situations where outcomes are partly random and partly under the control of a decision-maker. An MDP consists of four main elements: states, actions, transition probabilities, and rewards. Imagine a robot in a grid world environment. The robot, our agent, navigates through cells to reach a goal, receiving rewards or penalties. Now let's talk about Q-Learning, one of the most popular algorithms in reinforcement learning. In Q-Learning, we use a table called a Q table that records the quality of each action in a given state. The Q value represents the expected future reward for taking a certain action in a particular state. The agent starts by exploring the environment, taking actions randomly, and updates its Q values based on the rewards received. Over time, the agent builds up a Q table that guides it to take actions that maximize rewards. So, to sum it up, Markov decision processes help define the environment and rules, while Q-learning enables the agent to learn the best actions by updating its Q values based on rewards. If you enjoyed this video and want to learn more about reinforcement learning algorithms, make sure to like, subscribe, and hit the notification bell. See you in the next video.